The deep sea is often described as beginning at the edge of the continental shelf and the bottommost zone in the sea. The depth of the continental shelf varies around the world, but on average it is around 200 meters. The average depth of the sea is around 4,000 meters, almost 2.5 miles, and the deepest point in the Mariana Trench is about 11,000 meters, so there's a lot of deep sea around the world. In fact, about 90% of the world's ocean is deep sea. Plant and animal matter from the euphotic zone, the uppermost zone where enough sunlight can get through to allow phytoplankton and other plants to photosynthesize, sink through the water column and eventually reach the deep sea. This falling dead and decaying organic matter is known as marine snow, and most deep-sea animals rely on it as a food source. The deep sea is home to a plethora of deep-sea creatures. The term deep-sea creature refers to organisms that live in the pelagic zone. The pelagic zone is the part of the open sea or ocean that is not near the coast or sea floor and is separated into different layers based on depth. The mesopelagic zone is one of them. The nominal depth delineation of this zone is between 200 and 1,000 meters below the ocean surface. Due to the limited sunlight penetration to the depths of this zone, it is frequently termed the twilight zone. Below in the bathypelagic zone, light no longer penetrates the water. It is a depth of about 1,000 meters in most open ocean systems, but can be much shallower along coastlines. It also has very low temperatures from 5 to 6 degrees Celsius. In addition, it has low biomass. Even further down is the abyssal pelagic zone, also called the abyssal zone or the abyss. It is about 3,000 to 6,000 meters below the continental shelf. Water hits 4 degrees Celsius here, and the zone is in near complete darkness with uniform environmental conditions throughout. Finally, the deepest layer is the hadopelagic zone, also called the hadal zone. Its depth is anywhere from 6,000 to over 11,000 meters below the continental shelf. At this depth, there is not enough light for photosynthesis to occur and not enough oxygen to support much life. To survive, creatures have slower metabolism which require less oxygen. They can live for long periods of time without food. Most of the food they get either comes from organic material that falls from above, which is marine snow, or from eating other creatures that have derived their food through the process of chemosynthesis. Chemosynthesis occurs in hydrothermal vents that allow organisms in deep-sea ecosystems to get energy independently from the sun. Cold seeping from the Earth's crust provides chemicals such as hydrogen sulfide for vent ecosystems in the deep sea. The geography of the deep sea is characterized by trench zones in complete darkness and extremely high water pressures. Much of the ocean floor in the deep sea is covered in organic ooze, which is made up of uneaten marine snow. This ooze collects as much as 6 meters every million years. The oceans cover 71% of our planet, with over half with a depth greater than 3,000 meters. Although our knowledge is still very limited, we know that the deep ocean contains a diversity of habitats and ecosystems, supports high biodiversity, and harbors important biological and mineral resources. Human activities are, however, increasingly affecting deep-sea habitats, resulting in the potential for biodiversity loss, and with this, the loss of many goods and services provided by deep-sea ecosystems. In the past, the main human impact affecting deep-sea ecosystems was the dumping or disposal of litter into the oceans. These activities were banned in 1972, but their consequences are still present today, together with the continuing illegal disposal of litter from ships and the arrival of litter and contaminants from coastal areas. In particular, the accumulation of plastics on the deep sea floor, which degrade into microplastics called mermaid tears that can be ingested by the fauna, has consequences still unknown but predicted to be important. Moreover, there is increasing evidence of the accumulation of chemical pollutants of industrial origins such as mercury, lead, and persistent organic pollutants in the sediment and fauna, including in species of commercial interest.